Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 59 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to teach you is I'm going to show you my solution to the homework assignment that I gave you in lesson number 58. But I should start by asking how many of you were successful. If you successfully did the homework, leave a comment down below. I am legend, double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Anyway, hopefully most of you guys got this because it was a straightforward extension of things that I'd already taught in the class. What am I trying to do? Reinforce the learning so that you apply the things that you learned in earlier lessons. And so hopefully this was a fun little and not too difficult project. But what the assignment was you were supposed to connect the joystick and the servo to the Raspberry Pi Pico W. Then I was supposed to get my big head out of your way so you could see. And then the idea being that the servo tracks the joystick. So if I take the joystick to 0 degrees, the servo will go to 0 degrees. Then as I move it on through 0 to 180, as I move the joystick around, the servo will track it. So I guess we can jump in and get busy here. The thing that I should probably do is very quickly just recap what my wiring diagram is. The joystick is just like it's been in the past, but in case you've missed those lessons, I will recap it really quick. If you look at these pins coming out of the joystick, you will see that there's a G and D for ground. The ground wire will go to physical pin 38. The ground wire goes to physical pin 38. The wire that is labeled 5 volts, the pin that is labeled 5 volts on the Raspberry Pi Pico W, that actually needs to go to 3.3 volts because the Pico W is a 3.3 volt component. So we would need to take that to physical pin 36. Okay, so you've got physical pin 38, 37, 36 is where I have the 5 volt pin from the joystick connected to. Then the next pin is VRX, and that is GPIO pin 27, and then VRY is connected to GPIO pin 26. Now notice sometimes I say physical pin and sometimes I say GPIO pin. Well, this is a little handy card that comes in your Sunfounder kit, and you can see that the physical pins are labeled in black, and that's just numerically. You start in the upper right when it's oriented like this. You go 1 through 20, then you go around the bin and you go 21 through 40. And so when I'm specifying something like 5 volts, 3 volts, or ground, I give you the physical pin number. But then when we're using GPIO pins, we use GPIO pin number. And so when I say GPIO pin 27, that would be this one, GPIO pin 27. GPIO pin 26. I start talking GPIO language, and that is physical pin 33 or physical pin 32 and 31. Okay, so that makes sense. Now on the servo, it's very simple. You have 3 pins. One pin is 5 volts. That's the red wire. The red wire coming off the servo is 5 volts, and 5 volts really means 5 volts this time. So this comes to physical pin 40, which should be able to give you 5 volts. And then brown, the brown wire is ground, so brown goes to ground, and that is physical pin 38. And now we have the orange pin, which is control, which will go to GPIO pin 15. Okay, GPIO pin 15. So now everything's hooked up. Anytime we use this servo, I have to warn you that you can power these little servos from the kit from the Raspberry Pi Pico W. But if you're doing anything bigger than these little bitty ones, then what you need to do is you need to not use the Raspberry Pi Pico W for your power supply. You need to connect it to an external power supply, and that external power supply should be 5 volts, and it should supply sufficient current to drive your servo. Okay, and then what you need to do is you need to connect the ground of the power supply to the ground of the Raspberry Pi Pico W to the ground of the servo. So all your grounds need to be hooked together. The Raspberry Pi Pico W can control a servo of any size. It can control a servo of any size, but for bigger ones, you need to power them not from the Pico, but you need to power them from an external power supply. Enough said. Okay, now we remember that we learned earlier how you control a servo is with a PWM signal. And I did a whole lesson on that. It was lesson number 36 in this class. I explained all the business of how this works with PWM, or pulse width modulation. I'm not going to redo all of that. If you don't remember it, go back and watch lesson number 36. But what I will do is, we know that we will be getting a degree value from the joystick between 0 and 180 degrees, and we have to convert that desired degree into a PWM val that we put on the servo to get the desired degree. So we have to do an equation in math. If you don't remember this stuff, go back and watch lesson number 36. But let's just jump in and let's see if we can do a little math real quick here, okay? So what we remember from lesson number 36 was that if you want to operate the servo, you need to have a PWM frequency. The frequency needs to be 50 hertz. That means that you go through the cycle 50 times in a second, 50 hertz. So that's one thing. What we also learned with the servo in lesson number 36, that if you want the servo to be at 0, you need to apply a duty cycle of 1638. So if you want 0 degrees, you apply a PWM signal of 1638 to the servo. Again, I explained it ad nauseum in lesson number 36, so I won't go over that again. Also, we learned that if you want 180 degrees, you need to apply a PWM signal of 8191. And then for all the in-between values, between 0 and 180, you want to scale between those numbers 1638 and 8191. How would we do that? We would do that with a line. If we're going to create the equation of this line, what's the first thing we need to do? We need to calculate the slope. And slope is what? It is y2 minus y1 over x2 minus x1. Okay, what's y2 over here? It is 8191 minus y1, which is 1638. Okay, so far so good. And then all that over x2, which is 180 minus x1, which is 0. And then you can do 8191 minus 1638 equals in your calculator, and then divide the whole thing by 180, and then the number that you are going to come up with there, is 36.41. That's the slope. Now with the slope, how do we get the equation of the line? The way we get the equation of the line is y minus y1 is equal to m onto x minus x1. Now we just put in the values. Y minus y1, what was y1? It was 1638, is equal to m, the slope, 36.41 that we just calculated, onto x minus x1. What was x1? x1 was 0. Right, now we have that. We have y minus 1638 is equal to 36.41 times x. And now we need to add 1638 to both sides of the equation. Y is equal to 36.41 times x plus 1638. Now we just got to go in and substitute our real variables in for the x and the y. Well, y is what? That's the value that we want to apply to the servo. And so that is our PWM val. And that is equal to 36.41 times what? Times what we started with, our desired angle. And so we'll just call that degrees plus 1638. Okay. So when when the potentiometer, or when the joystick gives me a degree, then I use this equation, and that will convert that degree to the PWM value that I need to apply to the servo. So I think we've got quite a bit of the problem solved just by doing that simple little bit of math. But now we need to jump in, and I don't want to write that whole program. Again, I don't want to write that whole program again to control the joystick, because remember last week we wrote the program that would look at the joystick and tell you what angle you were at. And so I want to pick up with where we left off there. So I will need you to come over to the most excellent www.toptechboy.com, and you can use this happy little search icon here, and you can search on something like calibrating a joystick for positional angle, and you should come to this lesson. You can come down and you hit the two little page icon, and then you've copied that program. Then you come over here to our friend Bonnie, you paste it in. And now I should have the program working if the universe is in proper working order, where at least I am monitoring the position of the joystick. So I will need everyone to hold their breath. Boom. Okay, so that is working. And so the third number over is the angle. So if I go all the way to the right, I'm getting an angle like 0. Upper right is 45. I go straight up and I get 90. I go up to the left and it's 135. And then I go all the way to the left and it is 180. So I am mapping that 0 to 180 on the joystick. Now I need to take that angle and I need to apply it to the joystick so that to the servo, so that the servo tracks the joystick. Okay. Hopefully that makes sense. This should be pretty easy at this point. So we're going to come in, and the first thing that we're going to need to do is, give me just a second here. Okay, the first thing we're going to need to do is kind of get that servo set up, because we set up the joystick up here, but now we got to set up the servo. And so what I'm going to do is the servo pin. Where was that servo pin? It was, if you remember, GPIO pin 15 over here. So that servo pin is going to be pin 15. And then what I'm going to need to do is I'm going to need to create a servo object, which is going to be using machine.pwm. So I'm making that pin 15, I'm making it a PWM pin. And how do I do that? By setting machine.pin, connect that to what? Servo pin, close, close, boom. So now that should work. Now, if I'm thinking about it right, now, I need to go ahead and set the servo frequency. And as we learned in 36, and I reminded you a minute ago, the servo dot frequency needs to be 50 hertz, like that. That's good. Now I'm going to go ahead and set a duty cycle of what was that, of 1638, because I always just want to start the servo at the 0 position. But who knows how this horn was put on there? So I'm going to take the horn off, and now I'm going to set the servo to 0, and then I'm going to put the horn back on where the 0 is where it should be. So the way we're going to do that is I am going to say servo.duty underscore unsigned 16, like that. And then I am going to set that to 1638. Okay, 1638, like that. And that should put it in the 0 position. So I'm going to go ahead and run this, and it's not going to be responding to the joystick, but at least it should set this to the 0 position. And so I'm going to run this, and PWM, what is that? What is that nonsense? Where did I go wrong? Line 11. Oh, servo frequency. There's a much better way to write that, and that would be without an equal and just open, close, like that. I will need you to hold your breath this time. Okay, so now the servo has moved itself to the 0 position. Now this horn with this little longer leg, I want to point that all the way to the right. And so now 0 in the software, 0 in the PWM, matches physical 0 on the servo. Now before I go on, I want to see 0 is right, but will 180 really give me 180? And we said, what was the PWM val a second ago to give you 180? That would be 8191. So now if I run the program, this should switch the other way. And then we know that we have basically the servo working correctly. Boom. Okay, you see that came all the way over to 180 degrees, and so that works. Now I'm just going to go ahead and I'm going to set this back to 0, like that. Okay, and now we need to come in and we need to put our equation in. So we're going to come down here, and down here towards the bottom, I've got the degree calculated. I calculate the degree from the joystick, and then I do some corrections in case there's a little noise, and I do some things to make it behave a little bit better. But then down here I have degree, but what do I want? I want PWM val. And how do I get PWM val? Who's your friend? Math. Who's your specific friend? Mr. Linear Equation that we just derived. And what did I say? That was 36.41 times degree that we have, plus 1638, like that. So now that should take the number from the joystick and it should apply it to the servo. But a couple of things that I have to think about, okay? What do we do if it's in the neutral position? There's no angle. And no angle is different than 0 angle. It's just, it could be anything. So if I am very close, right, I did this magnitude thing that's looking if you're very close to the neutral position. I just want to go ahead and arbitrarily make the degree there 0 so it doesn't sit and just jump around at that position. So I'm going to deliberately set degree to 0 if it is sitting here. And then if I come over to 0, it'll stay at 0. And then as I go around, it should go around. There's one other thing that we need to do, and that is that I can only go from 0 to 180. Now, the joystick will go on to 270 and to 360, okay? But I can only use 0 to 180. So I need to put some if statements so that I don't try to drive that servo out of range. So I'm going to say if degree is greater than 180 and degree is less than 270. So that's saying if it's between here and here, if it's between here and here, go ahead and make it 180. Okay, so if it's between 180 and 270, we're going to make it degree is going to be equal to 180. Okay, now there's one more over here, and now this is 0, but if I come down just a little bit, that's going to go to 360, and I don't want a 360 or a 359 to switch all the way over to 180. So if I'm between 270 and 360, what do I want to have happen? I want degree to be 0. So between here and here, I want to stay at 0. So what I would say there is if degree is greater than 270 and less than, and degree is less than or equal to 360, then what do I want to do? I'll just say degree is equal to 0 because I want it to stay over here. I don't want it to jump back to 180. Hope that makes sense. Okay, now I have calculated my PWM value. Now the one thing that I still need to do is I need to apply that. Okay, so now I'm going to say servo.duty. Okay, unsigned 16. Now what we know is PWM val is going to be a floating point number because the degree might be an integer, but if you multiply an integer by a float, you're going to get a float every time. And in fact, degree might actually be a float as well. So if you multiply a float by a float, you're going to get a float. But what does duty cycle want? It wants a round number, an integer. So here I'm going to go ahead and say int. I'm going to take the int value of PWM val like that, close the int, close the servo duty. And now, just for good measure, we better put a time dot sleep of, let's say, a tenth of a second, 0.1, and that way we're not just sitting there and pounding that servo too hard. Okay, so let's see. Let's see what we've got here. All right, let's see. Are we ready to run this? I hope so. I will need everyone to hold their breath this time. Okay, so I'm going to stop this. Also, it might be interesting that we can just kind of watch here. What I'm going to do is I'm going to print degrees so you can see the degrees that we're getting from here, and then we should see that degree match here. So everyone hold your breath. Boom. Okay, 0 degrees as we expected. So what am I going to do? I'm going to come over here to 0 degrees. And if I miss it a little bit, it doesn't swing all the way around. Now, I'm going to take it slowly from 0 to 45 degrees, from 0 to 45 degrees. And when the joystick is at 45 degrees upper right, what is it? The servo is at 45 degrees. I take the joystick to 90, the servo goes to 90. I take the joystick to 135, upper left, the servo goes to 135. I take the joystick to 180, and the servo goes to 180. And I can go smoothly between all of those different values. Boom. Okay, guys, we have had success. Now, what I hope is, I hope you guys are enjoying these things, and I don't want you guys to get bored. I don't want you guys to get bored with these lessons, but I want you to apply the things that you learned in earlier lessons to new lessons so that we reinforce the lessons. I'm going to do one more thing with the joystick, and what I want you to do is I want you to get your NeoPixels out again, and then what I want you to think about is I want you to think about that HSV color wheel. Okay, the HSV color wheel, and that is what, from 0 to 360 degrees. So what I want you to do is to take your joystick, and on your joystick, as you go from 0 around to 360 degrees, I want you to take your NeoPixel from the color on the HSV color wheel. I want you to take it through that rainbow from 0 to 360. So you take your NeoPixel colors all the way through the rainbow based on your position here. So it's very similar to what we did here, but now instead of applying the angle of the joystick to the servo, you're applying it to the NeoPixel to get the color you want. Okay, guys, I hope that makes sense, and I hope that you will post your homework assignments, right? That when you do this homework, then make a video, post the video to YouTube. Down in the comments, leave a link over to your homework solution, and then down in your description, link back to this video so people know what you're doing. And I look at every single homework assignment for all of my classes that you guys post. I look at every single one of them. Okay, now as always, I do want to give a shout out to you guys that are helping me out over at Patreon. Right now, you're the ones that are keeping me in the game. It's because of your help and coming along beside of me, I keep this great content coming. You can also help me by giving me a thumbs up or leaving a comment down below. If you have not already, make sure that you subscribe to the channel. When you do, ring that bell so you'll get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.